Hello everyone, welcome to the lecture series of course Computer Architecture. So today we are going to learn the topic machine instructions and programs. Let's start. Machine language is the instruction in form of binary zeros and ones, and it is directly executed by the hardware. Whereas assembly language consists of pseudo instructions and it is low level symbolic version of machine language. High level language is more readable like C, C++, Java, which we use for programming. Assembler is used to translate the assembly language into machine language, whereas compiler is used to translate the higher level languages like C, C++ into assembly or machine language. As we know, processor consists of special function registers and general purpose registers. So we are going to see special function registers present in MIPS 32 processor. So there are two types of special function registers are present in MIPS 32. SFR used for interfacing with primary memory and SFR used for keeping track of program instructions. So as we know, instructions and data are stored in the memory. So to execute the instructions with data, it must be transferred from memory to CPU. So for that we use two special function registers, memory address register and memory data register. So memory address register holds the address of memory location to be accessed and it is unidirectional, whereas memory data register holds the data that has been written into the memory or will receive the data that has been read out of the memory. Hence, it is bidirectional. So, from this diagram, you can get the idea of how MAR and MDR works. So, only MAR and MDR can directly contact with the primary memory. So here you can see MAR is unidirectional as it holds the address of instruction to be executed, and MDR is bidirectional because it holds the data that has been written into the memory or read out from the memory, and there is a control signal like read and write to control the operation. Now let us understand how the data can be read out from the memory and data can be write into the memory. So data read from memory, it includes three steps. First, load memory address into MAR, then issue the control signal read. After that, data read from the memory is stored into memory data register. And to write the data into memory, we also require three steps only. First, load memory address into MAR. Second, load the data to be written in MDR. And we need to issue the control signal right to control this operation. Now the second type of SFR is SFR for keeping the track of program instructions. There are again two SFRs. First is program counter PC. It holds memory address of the next instruction to be executed, and program counter gets automatically incremented to point the next instruction when current instruction is executed. And the second SFR is instruction register. It temporarily holds the instruction that has been fetched from the memory, and then it is decoded into type of instruction, whether it is R type or I type, etc. Let us see the example. Here we have taken the instruction add R1 R2, which means it performs the addition of memory content of register R1 and memory content of register R2 and stores the result back into the R1. So first step will be the content of PC program counter will be transferred to memory address register, And then the content of memory address register is transferred to MDR, which means now instruction will be in memory data register. Then the content of MDR is transferred to IR, where the instruction is temporarily stored and it is decoded into its type. After the instruction decode, PC will increment by PC plus 4, and this new PC value will be stored into PC, that is program counter. After decode, we perform the actual instruction, that is R1 plus R2, and the result will be stored into R1. So this was about SFRs present in the MIPS 32 processor. Now let us understand about the general purpose registers present in the MIPS 32. So older architectures used to have more number of SFRs and smaller numbers of GPRs, but now newer architectures have large number of GPRs because registers are much more faster than the memory, and it is easy for the compiler to assign some variables to registers, and more compact instructions can also be encoded as fewer bits required to specify the registers. So generally most of the processors have 32 GPRs, and MIPS 32 also has 32 GPRs. This is the list of 32 GPRs with the register number, name and their use. You can refer. For example, 0 register is used to store the constant value. There are some temporary registers from register number 8 to register number 15. There are some saved temporary register which can be preserved across call, and along with these there are some registers like stack pointer, frame pointer, pointer to global area, etc. You can refer this chart for total 32 GPRs present in the MIPS 32 processor. Then the next point is instruction set architecture. Instruction set architecture serves as a interface between software and hardware. It contains instruction set, addressing mode, registers, address bus and data bus. So instruction set architectures are not really specific for the computer architecture. So there are 5 design parameters for instruction set architecture. First, number of operands, whether the operands are 0, 1, 2 or 3. Then the location of operand, whether the location of operand is register or memory. Then the specifications of operand location, like addressing modes. So there are different addressing modes present in MIPS 32 like direct, indirect, register addressing mode and immediate addressing mode. Then the fourth parameter is size of operand supported, whether the architecture supports byte, half byte, word or double word, etc. And the fifth design parameter is supported operations like arithmetic, logical and data transfer. For this time being, this is about machine instructions and program. You will learn instruction format in next video. Thank you.